So module 4, infinite sequences. So first I will define what is infinite sequence. So an infinite sequence or sequence is an unending succession of numbers. That means we are writing numbers in a definite order, and these numbers are called terms, have a definite order. That is, first term u1, second term u2, third term u3, and so on. Such a sequence can be written as, so this is the order. So the first term u1, u2, u3, etc., un, etc. And it has a notation set un n equal to 1 to infinity. Okay, now we will check out few examples. So first example, sequence and their notation. 1 by 2. Here the first term is 1 by 2, second term is 2 by 3, third term is 3 by 4, fourth term is 4 by 5, and etc. In general, nth term is n by n plus 1. That means if n equal to 1, we will get 1 by 1 plus 1, that is 1 by 2. N equal to 2, we will get 2 by 2 plus 1. And its notation is, right, n by n plus 1. So n equal to, this sequence can be written as n equal to 1, 1 by 1 plus 1, 2. And the second term, 2 by 2 plus 1, 3, etc. And another sequence is 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 2 raised to n, etc. etc. Okay. So its notation is 1 by 2 raised to n. So these are few other examples, and now we will check what will be the value of the sequence as n is going very large. That means what will be the limit of the sequence. So limit of a sequence. If sequence un n equal to 1 to infinity tends to a limit n, then we write limit n tends to infinity un is equal to L. If the limit of a sequence is finite, the sequence is convergent, otherwise divergent. That means if you have a sequence un, you just check it out what will be the limit as n tends to infinity. If this limit is finite, that means it's finite, then we call the sequence is convergent. And if the limit is infinite or minus infinity, we say that sequence is divergent. So first we will check it out this. So first question, determine whether the sequence is convergent or divergent. So we have the sequence un n equal to 1 to infinity is equal to sequence, first question A, n by 2n plus 1 n equal to 1 to infinity. So it implies here un is equal to n by 2n plus 1. Now we will take the limit. We have to check whether this sequence is convergent or not. Now we will check it out. Limit n tends to infinity un is equal to limit n tends to infinity. What is un? un? What is un here?
n by 2 n
n,
plus 1.
n by 2n plus 1. This is equal to limit n tends to infinity. So I am taking n into 1 divided by, if I take n outside, n into 2 plus 1 by n. So I can cancel out this n and n. So limit n tends to infinity 1 by 2 plus 1 by. So as n tends to very large, you know that limit n tends to infinity 1 by n. What is limit n tends to infinity 1 by n? As n tends to very large in the denominator, what will happen in the whole term? What is this limit? This goes to 0, right? As n tends to very large, you know, 1, 1 by 2. It's decreasing, right? 1 by 3, etc. 1 by n. As n tends to very large, 1 by 1000, 1 by 10,000, etc. So as n tends to very large, this goes to 0. So this limit you will get 1, this goes to 0, 1, 2 plus 0, 1 by 2. So this is a finite quantity. Then what you can tell about the sequence? Is it convergent or divergent?
Convergent.
Convergent because it has a finite. Now what about second problem? Here sequence un is equal to 8 minus 2n n equal to 120. Now we want to check whether it is convergent. So limit n tends to infinity 8 minus 2n. This is equal to limit n tends to infinity 8 minus 2 times limit n tends to infinity n. So limit, what is limit n tends to infinity 8?
8.
It itself because it's a constant minus 2 times. What is limit n tends to infinity? Infinity is infinity, right? It goes to infinity. So you will go, you will get this goes to minus infinity, right? 8 minus 2 infinity, that means that this doesn't have a finite limit, not have finite limit. Then what you can say about this sequence is it divergent or convergent?
Divergent.
Divergent. Divergent. Very good. Now we will move into what is infinite series. So this is the very important topic. So definition. If you have a given a sequence un n equal to 1 to infinity, an expression of the form here sequence is un n equal to 1 to infinity u1 plus u2 plus u3 plus etc. un plus etc. is infinite series. If you have a sequence un, then the form see expression u1 plus u2 plus etc. plus un plus etc. is called infinite series, and this can be notated as written as sigma n equal to 1 to infinity un. So this means when n equal to 1 u1 plus u2 plus u3 un. Now, for example, we can take an example. If I have a series n equal to 1 to infinity 1 by n square. So actually this is 1 plus 1 by 2 square plus 1 by 3 square plus etc. 1 by n square plus etc. So this series is called, this is an example for a series. So now our aim is we have to find the sum of the series, or we have to check whether a series is convergent or not. So for that we will define a new sequence of partial sums. Okay, so consider a series, infinite series, sigma n equal to 1 to infinity un. Let Now I am defining a new sequence. For that I am defining what is S1. S1 is the first. I am defining a new sequence. Sn equal to n equal to 1 to infinity. So the first term u1, second term u1 plus u2, third term u1 plus u2 plus u3, etc. Nth term is equal to u1 plus u2 plus u3 plus etc. un. And this is simply equal to sigma k equal to 1 to n uk. Then the number Sn is called nth partial sum of the series, and this sequence S1, S2, etc. Sn, Sn, etc. is called a sequence of partial sum. This is called a sequence of partial sum. That is this sequence. Now, why we define this sequence of partial sum? In order to check whether the series is convergent or not. Now, okay, so let the S1, S2, etc. be sequence of partial sums of the series sigma k equal to 1 to infinity uk. If the sequence S1, S2, etc. converges to a limit S, then the series is said to converge to S. Okay. That means when the series is convergent, the series is convergent if and only if the sequence of partial sum converges. So, in order to check whether the series is convergent, it's enough to check the sequence of partial sum converges. And S is called the sum of the series. If this converges to a sum, then the S is called sum of the series. If the sequence of partial sum diverges, then the series is said to diverge. That means the series is convergent if and only if sequence of partial sums converges. Okay. Then a divergent series has no sum. That means the sum is minus infinity or infinity. So that's clear. So now we will define a very important and very simple topic that you already studied, geometric series. So this is a very basic series, and I will define what is geometric series. A series of the form sigma k equal to 0 to infinity a r raised to k is equal to a plus ar square plus ar cube plus etc. a raised to a r raised to k plus etc. where a not equal to 0 is called a geometric series. Now we know that a geometric series sigma k equal to 0 to infinity a raised to a r raised to k is equal to a plus ar plus ar square plus etc. a r raised to k plus etc. This converges when this r modulus of r less than 1 and diverges if modulus of r greater than or equal to 1. So, when is series converges, this r is greater less than 1 and diverges if r greater than 1. If the series converges, then the sum is sigma k equal to 0 to infinity a r raised to k is equal to a by 1 minus r. A by 1 minus. Now tell me. Now I will give you a few examples. So what is the first example? 1 plus 2 plus 4 plus 8 plus 2 raised to k plus etc. 2 raised to k. Okay. Now here a equal to 1. What is the first term? A equal to 1. What is r? What is r here? Tell me R. Tell me what
2.
is it? 2, right? 2, 2. So here A equal to R and R equal, sorry, A equal to 1 and R equal to 2. So is this convergent? Here R equal to 2. Is this series convergent? No,
Divergent.
because R is greater than R equal to 2, R equal to 2, which is greater than 1. Divergent. What about this series? 3 by 10, 3 by 10 square, 3 by 10 cube, etc. What is the first term? A equal to 3 by 10 and common ratio R equal to 1 by 10. Is this series is convergent?
Yes, sir.
Yes, because R is uh,
Is less
1 by 10
Less
and
than 1.
less than 1, right? So the sum is, you know that A by 1 minus R, you can find sum. 3 by 10 divided by 1 minus 1 by 10, which is equal to 3 by 10 divided by 9 by 10, which is equal to 3 by 9, 1 by 10. So this is the sum. Okay, similarly you check it out this, and I will today I will send you notes. Now next question is determine whether the following series is convergent. If so, find the sum. So I will do this problem. Here what is sigma k equal to 0 to infinity 5 by 4 raised to k. So when k equal to 0, 5 by 4 raised to 0 plus 5 by 4 raised to 1 plus 5 by 4 square plus 5 by 4 cube plus etc. 5 by 4 raised to k plus etc. Now what is the first term? A here. This is actually, this is a geometric series, right? So tell me what is A? First term
5.
5.
5.
Second term, sorry, what is R? Common ratio
1 by 16.
1 by.
4. 1 by 4.
Therefore, what is the sum? Sigma k equal to 5 by 4 raised to k is equal to, sum is A by 1 minus R, right? So A is 5, 5 by 1 minus R. R is 1 by 4. That is 5 by 3 by 4, which is equal to 20 by 3. So the sum is 20 by 3. Now you write down, tell me what is the, solve this problem. Sigma k equal to 1 to infinity minus 3 by 4 all raised to k minus 1.